Alright, give this a shot. Which of the following is not a correct derivative? I'm going to go through each one by one and figure them out. So, A, derivative of cosine x is negative sine x. Yeah, that's a good one. Just memorize the basic trig derivatives. Derivative of 1 minus x cubed is negative 3 1 minus x squared. This would be a chain rule problem. So you would bring down this power. You'd have 3 1 minus x squared. And then through the chain rule, you'd take the derivative of this negative x here. And you would have a negative 1 up front. And that would leave you with negative 3 1 minus x squared. So that one's good. And if you're not too familiar with chain rule, you would maybe call y 1 minus x cubed. You would do dy du is equal to du dx. So you'd substitute a u in here. This would be equal to u cubed. Dy with respect to u would be 3u squared. Now you'd have to find this du dx. So you know u is 1 minus x because you put the u in for that. 1 minus x, du dx is negative 1. And then you would multiply this negative 1 by that 3u, negative 3u squared. You'd plug in the 1 minus x squared, and you can see that you're getting that problem. So that's just a chain rule. If you're not familiar with that, go find some other video. This is just like kind of a refresher and, you know, show you what you need to know for the test. So now that we're on C, derivative of 1 over x is equal to negative 1 over x squared. Yeah, whenever you have your variable in the denominator, you're going to make it negative, and then you're going to go to the next power. So that's right. That's just another thing with derivatives, like when you're just dropping powers, because that's technically a lower, because you're going from like x to the negative 1 to the x to the negative 2, you know, that kind of thing. So that one's good. So clearly this one's fucked, because these are all good, right? And you could use the quotient rule. 1 over cosecant would be 1 over sine, and then you could do the quotient rule from there. But this is also in the book. You can just go to your derivative table, and you can see that by the derivative table, this is wrong. So this would be your answer.